Hey, what's up, guys? We're back. I wanted to take a look at a couple of problems that were requested, 20 through 22. I also want to take a look at problem 17, and I told you in yesterday's video that I'd show you another way to do 24. So let's start with that. We want to do the derivative of the quantity x over x plus 1 to the fifth. Yesterday we left it as is and did the chain rule, right? 5 quantity x over x plus 1 to the fourth, and then we had to do the derivative of the inside, which was a quotient rule. However, I want to show you another way that we can do this and get the same answer. It's just kind of cool to see both ways. One thing you can do is take your function x over x plus 1 to the fifth and use our property of exponents to rewrite this as x to the fifth over x plus 1, that quantity, to the fifth power. Now we have a quotient rule that's going to have a chain rule component to it down at the bottom. So let's take a look at what that would look like when we do its derivative. So again, quotient rule says we do the derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Here's what that looks like. So our answer is, right, if we're doing the derivative of this, our answer is the derivative of the top, which is 5x to the fourth, times the bottom, which is x plus 1 to the fifth, minus the top, x to the fifth, times the derivative of the bottom. Now the derivative of the bottom here is a chain rule, which will be 5, quantity x plus 1. We do the derivative of the outside with respect to the inside, keeping that x plus 1 the same. Then we need to multiply by the derivative of the inside, which nicely here is simply 1. And we take that all divided by the bottom squared, which is x plus 1 to the fifth squared. Once again, this is the actual derivative here, but this problem is a multiple choice problem, and it looks absolutely nothing like any of the 4 choices that we have. So this is where we need our simplification skills to be really good. So let's take a look here. I'm just going to clean this up a little bit. The first part is already good. 5x to the fourth, x plus 1 to the fifth. That second term on top, let's just call it 5x to the fifth, x plus 1 to the fourth. And on the bottom, x plus 1 to the fifth squared would be x plus 1 to the 10th. Remember, power to a power, we multiply exponents. Right now we can see that the term x plus 1 shows up in all of them, and we can cancel out a grand total of 4 of those. That's our greatest common factor, which is going to totally wipe out this x plus 1 to the fourth. It's going to change this x plus 1 to the fifth into x plus 1 to the first. And it's going to change this x plus 1 to the 10th into x plus 1 to the 6th. And we're left with this, 5x to the fourth times x plus 1. Notice it's to the first, I don't need to write that. Minus 5x to the fifth over x plus 1 to the 6th. Now that's starting to look more like the answer choices, but it's still not there, right? So we can do one more simplification by distributing that 5x to the fourth into the x plus 1 right here. If we do that, we get 5x to the fifth plus 5x to the fourth minus 5x to the fifth over x plus 1 to the 6th. We see that our minus 5x to the fifth and our 5x to the fifth cancel, and we're left with the correct answer choice of 5x to the fourth over x plus 1 to the 6th. Same as when we did it the other way in yesterday's video. I don't know if one way is easier to me than another. Some people might feel the first way was easier, some people might feel the second way was easier. Just know that you have options, and when you're taking the test, don't be afraid to, if it's not working one way, try a different way. Either way, there's some tough simplifications here that we just got to fight our way through to get to the right answer. Okay, let's look at problem 17 real quick. We want slope of tangent line to y equals cosine of 7x when x equals pi over 42. One thing I want you to understand when you look at this problem is I'm only asking for the slope of the tangent line, not the equation of the tangent line. So I don't need to find a point and the slope. All I need to find is the slope. The other thing that might concern you is seeing that pi over 42, right? That's not one of our ones from the unit circle that we're comfortable with. Don't worry about that, because oftentimes it works itself out back into one of the easier ones that we actually know how to do. So again, slope of the tangent line is the biggest code word for derivative that we know. So obviously we want to find the derivative of y with respect to x. So taking a look at that, I'm going to find dy dx. Then I'm just going to plug in pi 40 seconds into that. So dy dx would equal, okay, I have the function cosine of 7x. This is clearly a chain rule problem because I have a function 7x within another function cosine of x. So I need to do the derivative of the outside, which is negative sine, with respect to the inside. So negative sine of 7x. I'm seeing a lot of people put negative sine x, 7x. It's not correct. It's not negative sine x, it's negative sine of 7x. We keep that inside the same. That's the derivative of the outside with respect to the inside. Don't forget to chain on your derivative of the inside. The derivative of the inside is 7. So cleaning that up, I get dy dx equals negative 7 sine of 7x. So that's our derivative with respect to x. Now I want to evaluate this at the x value of pi 40 seconds. So the notation for that looks like this, dy dx. I put that big bar and then I say x equals pi over 42. And I'm going to just plug in pi over 42 everywhere I see an x. There was only one place that had an x. And now I can see why I don't need to be worried about my pi over 42, because I'm multiplying that by 7. So I get 7 pi over 42. Both of these divide by 7, so I end up with 1 pi over 6. So this equals negative 7 sine of pi sixths. A much easier one that we already know. When we look at the coordinate for pi 6 radians, we see root 3 over 2 comma half. Sine is always the y coordinate, so that's half. So I have negative 7 times 1/2, which equals negative 7/2. Okay. Let's take a look now at problem 20. Problem 20 says g of x equals the arc cosine of 8x squared minus 4. And I want to know g prime of x. So again, all I'm doing here is the derivative. I don't need to evaluate it. I don't need to write an equation of a tangent line. To do this derivative, we need to know the framework for the derivative of the arc cosine of x. Well, that's very similar to the arc sine of x. It's just negative. But again, I'm not doing the arc cosine. I'm not doing the derivative of the arc cosine of x. This is a chain rule problem because I'm doing the arc cosine of 8x squared minus 4. So again, it helps to know this. right? The derivative of arc cos of x is negative 1 over the square root of 1 minus x squared. So if I want to do the derivative of the arc cos of 8x squared minus 4, I'm going to get g prime of x equals negative 1 over the square root of 1 minus, instead of plugging in x, I'm doing the derivative of the outside with respect to the inside. That 8x squared minus 4 has to stay the same, and it has to be squared. Then I need to multiply. Don't forget to chain on here. A lot of people are forgetting this. You can't do it. We got to chain on the derivative of the inside. The derivative of the inside is simply 16x. Cleaning this up a little bit, I'm just going to put that 16x on in the numerator with the negative 1, multiply them together and get negative 16x over the square root of 1 minus 8x squared minus 4 squared. Now, generally, when I see these problems and their solutions on the AP practice exams and things, if we have a binomial squared, they leave it as is. If it's a monomial squared, they'll simplify that. Because 8x squared minus 4 is a binomial, I'm just going to leave it as 1 minus parenthesis 8x squared minus 4, close parenthesis, squared. I'm not going to FOIL that thing out. Okay, you might have to do that, but probably not, so let's leave it as is. That's problem 20. Let's look at 21. 21 is an arctan problem. We have f of x equals the arctangent of 2x to the 5th. This one's different because I'm looking now for f prime of 1. So I need to not only find f prime of x, but then I need to evaluate the derivative at 1. Right, we're looking for the slope of the tangent line to this graph at the x value of 1. Once again, I need to know arctan of x derivative to solve this, and then I need to adjust it because we're using the chain rule here. Arctan of x's derivative is 1 over 1 plus x squared. Notice that there's no square root. Notice that it's a plus in the denominator rather than a minus. That's how it differs from sine and cos. Okay, so let's, again, before I find f prime of 1, I need to figure out an expression for f prime of x. Here's what that looks going to look like. So this is the derivative of the outside, arctangent, but not of x, arctangent of 2x to the 5th. So I have 1 over 1 plus 2x to the 5th squared. But again, we can't forget our chain rule, right? We got to chain on the derivative of 2x to the 5th, which would be 10x to the 4th. We need to multiply by 10x to the 4th. Another thing here, sometimes when I see people doing these derivatives, they put times 10x to the 4th, but when they write it, it looks like it's in the denominator. That is not in the denominator. We are multiplying that whole fraction by 10x to the 4th. If you want, you can go ahead and just write it on top to begin with. Right? That might help you avoid making a mistake. I'm going to clean this up just a little bit before I evaluate at 1. Notice the 2x to the 5th squared. Notice how 2x to the 5th is a monomial. So they will simplify that. They didn't in problem 20. They probably won't in problem 20 because it's a binomial. But not monomials squared, they'll always simplify. So here's what it looks like. We have 10x to the 4th over 1 plus 4x to the 10th. By the way, since we're evaluating at 1, you definitely don't have to make that simplification on the bottom. You could just plug in your 1 with it unsimplified and it'll still come out correct with the correct answer. Okay, so it's up to you. We're not quite done with this problem. Now we have to do f prime of 1. Obviously, we see we have 10 times 1 to the 4th. That's simply 10 on top. 1 plus 4 times 1 to the 10th is 5 on the bottom. 10 over 5 is 2. All right. And let's take a look at 22 here. 22 says this. So I give you a function g of x, and g of x is defined as 4x e to the 2x plus 8. And we need our goal is to figure out g prime of negative 4. So just like 21, we got to get the derivative with respect to x, and then we have to go one step farther and evaluate that thing. Okay? So when you look at this function, g of x equals 4x times e to the 2x plus 8, what do you see, right? In your head, you need to be figuring out what rule or rules you need to use. Well, here's what I notice. I notice I have 4x times e to the 2x plus 8. Whenever I have function times function, I know I need to use product rule. So I'm going to have to use the product rule here. But the 4x doesn't concern me, but that e to the 2x plus 8, when I do that derivative, right, that's a function within a function, so I'm going to need to execute the chain rule only when I do that derivative, though. So let's go ahead and do the product rule. Product rule says derivative of the first times the second plus the first times the derivative of the second. Again, that rule needs to be absolutely rock solid memorized, along with the quotient, along with the chain. So let's look at g prime of x first. So let's do the derivative of the first. The derivative of the first, derivative of 4x is simply 4. And we multiply that by the second, e to the 2x plus 8. Notice how I didn't need a chain rule here, because the function I was doing the derivative of was simply just a power rule derivative. So that is the derivative of the first times the second. Now I need to add the first, 4x, times the derivative of the second. So I have to do now the derivative of e to the 2x plus 8. Well, that's a chain rule, so don't forget to just do the chain rule correctly. We do the derivative of the outside with respect to the inside times the derivative of the inside. Our inner function here is 2x plus 8. The derivative of 2x plus 8 is simply 2. Now I'm going to clean this thing up a little bit before, I like to do that before I evaluate. So here's what it looks like cleaned up. And I get this. G prime of x equals 4 e to the 2x plus 8 plus 8x e to the 2x plus 8. Now I'm ready to go ahead and find g prime of negative 4. Every single x I'm going to replace with a negative 4. I have 4 e to the 2 times negative 4 plus 8 plus 8 times negative 4 e to the 2 times negative 4 plus 8. What I see there in those exponents, both of them are 2 times negative 4 plus 8. That is negative 8 plus 8, which is 0. So those e's, the exponents on the e turns to 0. And I'm left with this. 4e to the 0 minus 32e to the 0. What is e to the 0? You better well say 1, because that's what it is. So we have 4 minus 32, which is negative 28. And that's the answer to problem 22. And I'm pretty sure that's all the ones I said I was going to do. Let's double check. Yep. So, if there are any more you want to see, please let me know before the end of the day so I can add one more video in to answer any last questions. Remember that the key is on Schoology. Sometimes you can figure it out from there. But if you can't, let me know. and I can do one more video before the end of the day. Shout out to Nick for reminding me that I forgot to end my video correctly. So here's the correct ending. 2 chains. See ya.